Decompose a fraction into a sum of fractions with the same denominator in more than one way, recording each decomposition by an equation. Justify decompositions, for example, by using a visual fraction model. Examples: 3 over 8 equals 1 over 8 plus 1 over 8 plus 1 over 8. 3 over 8 equals 1 over 8 plus 2 over 8. 2 and 1/8 equals 1 plus 1 plus 1 over 8 equals 8 over 8 plus 8 over 8 plus 1 over 8. Let's look at the first example over here. Now, we viewed 3/8 as 3 copies of 1 over 8. And so we can just write that out as an expression. Here's one copy, another copy, and another copy. So that's what we mean by 3 over 8. We can view it that way. And at this point, since they're all the same size, a good rule of thumb is, as long as the denominators are the same, we could simply add up the numerators to obtain the result. We can also view it in this regard: 2 over 8 plus 1 over 8. Let's look at this example more visually. So let's create 2 equivalent squares of area 1. The area represents the whole. And let's divide it into eighths. Let's do it this way. So it's not perfect, but it's roughly divided into 8 equivalent regions. And so let's view this one as 1 over 8 plus 1 over 8 plus 1 over 8. And let's view this one as 2 over 8 plus 1 over 8. Now, let's be very careful. Let's view this one as, let's take this, here's 1 over 8, here's another 1 over 8. Here's 1 over 8, here's another 1 over 8, and here's another 1 over 8. All together, let's let the dot represent a shading in, just because I don't want to get too messy here. Right? If this were shaded in, that would represent 3 over 8. Now let's look at it from a different angle. Let's view it as, let's start with 2 over 8 and then add 1 over 8. Let's see if we obtain the same result. Right now I'm starting off with this figure, 2 over 8. And now I have to add 1 over 8. And lo and behold, I do get the same figure, right? If this were shaded in, let's do that really quickly. I would get the same figure, right? They're both 3 dots. They're both 3 copies of 1 over 8. Seeing how we can decompose it, let's look at another example. Let's look at 5 over 6. We can view that as 1 over 6 plus 1 over 6. Of course, because it's 5 copies of 1 over 6, we can view that as 3 over 6 plus 2 over 6. And we can also view that as 4 over 6 plus 1 over 6. Let's just do a few examples here. So if we divide the region into sixths, let's let the shaded area of this denote the whole. So 5 over 6 could represent 1, 2, 3, 4, 5. Let's assume those dots represent a shading, right? This is separately, I obtained this. Now let's look at it as, I could start with 3 over 6, 1, 2, 3, and add 2 over 6. I still get the same thing. And here let's view it as 4 over 6 plus 1 over 6. I'll even outline it to make it clear. So this time I'm going to start with this 4 over here. 1, 2, 3, 4. Let's add 1. We still get the same result. So we can decompose it. The important thing is that if the denominator is the same, we can simply add up the numerators. Let's look at this example. 2 and 1 over 8. Now recall that from the number line, this is 0, this is 1 over 1, this is 2 over 1, this is 3 over 1, right? Let's be more accurate here. This is 0. 0 over 1 is the same thing as 0, it's just convention. So of course this is still 1, this is still 2, this is still 3. So we have different ways of naming whole numbers. So 2 over 1, let's look at it this way. 2 equals 2 over 1. Right? It's right here. It's pretty explicit. And according to the theory of equivalent fractions, we can multiply it by whatever we like. So let's multiply it by 8 to obtain 16 over 8. So now we have, let's look at it from a different angle. We have 16 over 8 plus 1 over 8. And we can add up the numerators, retain the denominator. We have 17/8 as the final result. Now let's look at this. I need to go to the next page, but let's look at, keep this result, 16 over 8 plus 1 over 8. So we have 2 and 1/8 equals 16 over 8 plus 1 over 8. Recall that we can decompose fractions as we like. So let's now think of this as 8 over 8 plus 8 over 8 plus 1 over 8. Well, this of course gives us 1, and this of course gives us 1. Right, and we can obtain the full result. 1 plus 1 is 2 plus 1/8, and we can write that as 2 and 1/8. Let's make that even more clear with a fraction model. So we have 3 squares. Let's let the area of 1 denote the whole. And let's again partition it into 8s. Careful here. So it's not perfect, but it will do. Suffice. Now, our original expression is 2 and 1/8, and we said we can view that either as 16 over 8 plus 1 over 8, or we can view it as, so we're going to look at all these angles from a visual standpoint. Again, let's let a dot represent that it's shaded in for clarity. So here's 8 over 8. Right, and we only have 1/8 here. Well, clearly from this perspective, all of these are filled in, so it would represent shading. Therefore, this is 1. Therefore, this is another 1, and this is 1/8. Right, that's looking at it from this perspective. Whoopsie daisies. Now let's look at it from the next perspective. Let's look at it as 16/8, so we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. That would again represent these two, and then plus 1/8. We get the same result. Let's look at the last perspective, which is 8 over 8 plus 8 over 8 equals 1 over 8. Well, what is 8 over 8? Let me do it in this color. It's 1, 2, 3, 4, 5, 6, 7, 8. That's 1. I just have completed this. Now let's complete this. This is 1, 2, 3, 4, 5, 6, 7, 8. And now let's complete this, 1/8. So altogether, no matter how I look at it, from a visual perspective, I get the same result. This is the same thing as this, which is equivalent to everything else that's circled.